Hello and welcome to Nikolai's genetics lessons, and today I have prepared another problem. In order to solve this problem, we have to know how to apply rule of probability. So here's a problem. A family has 6 children. Determine the probability that there are fewer than 3 male children in a family. So what is the statistical probability? First of all, how many combinations we may have when we have 6 children. So how many different combinations of sexes exist. So the first child can be whether a boy or a girl, so 2 variants here. The second child also can be a boy or a girl. The third, the fourth, the fifth, and the sixth. So every time this family would have a child, there are 2 variants, whether it's going to be a boy or a girl. So 2 multiplied by 2, 4, multiplied by 2 would be 8, multiplied by 2 would be 16, multiplied by 2 would be 32, and multiplied by 2 would be 64 combinations. So total number of combinations would be 64. And only combinations when family would have 2 boys and 4 girls would meet requirement of our problem, fewer than 3 male children. So 2 boys and 4 girls would be fewer than 3 male children. Another combination would be 1 boy and 5 girls, and the last combination would be when all 6 children would be girls. So as you see, out of many different combinations, we are looking for the frequency of only these 3 combinations that would give us fewer than 3 male, so 2 male, 1 male, and no male at all. The easiest to calculate would be all 6 girls. There is only one such combination exists. So all 6 children would be girls. So 1 out of 64 would be such a combination. It's also, we can easily say that number of combinations to have 1 boy and 5 girls would equal to 6. So the first child can be a boy, and then we can have 5 girls. Second combination, that second child would be a boy and the rest would be girls. Third combination would be that third child would be a boy. Fourth combination, that fourth child would be a boy. Fifth combination would be that fifth child would be a boy, and the sixth combination would be that sixth child would be a boy, and first 5 children would be girls. So as you see, total number of combinations to have 1 boy and 5 girls would be 6 out of 64. So total number would be 6 combinations, and total number of combinations would be 64. So the only probably difficulty would be to find number of combinations here. So how many combinations we may have here. And basically we just have to list all the possible combinations. I would start with first 2 children being boys. So first child boy, second boy, then a girl, a girl, a girl, and a girl. So 6 children, 2 boys and 4 girls. And this would be the first combination. Then what I'm going to do, in order to list all the possible combinations and not to lose any of the combination, I would leave the first boy here on the first place, but would move the second boy to the end of the list. When I would go to the end of the list, I would move the first boy to the second position and would return second boy to the third position, and also would move down the row. And when I would go down the row, I would move the first child to the third position, so probability of being born third child, and then second also would move down the road. So this is very fast and easy method. You don't need to know any formulas, you just can use logic. The only problem is not to miss any of the combinations, so we have to follow certain logical rules. So let's do it. So this is going to be our first combination. The second combination would be a boy, a girl, a boy, a girl, and a girl. Then a boy, a girl, a girl, a boy, a girl, and a girl, a boy, a girl, a girl, a girl, a boy, and a girl. Then a boy, a girl, a girl, a girl, a girl, and the boy. Now I will move this boy to this position, so and would return the second one to be in the third position. So let's find how many variants we have. So first child would be a girl, then a boy and a boy, a girl, and a girl, a girl, a boy, a girl, a boy, a girl, 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 boy, girl, girl, boy, girl, girl, boy, girl, 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 and a boy. So now one more time we are going to move this boy to the third position and would return this boy to the next position. So let's list next variants here. So a girl, a girl, a boy, and a girl, a girl, a girl, a girl, a boy, a girl, and a girl, a girl, a girl, boy, girl, girl, boy. So next variant would be when we would move this boy to this position and this boy next to him. So first three children would be girls, and then boy, boy, and a girl. A girl, a girl, a girl, boy, a girl, and a boy. And now the last variant. A girl, a girl, a girl, a girl, and two last children would be boys. So now we have listed all the possible variants. So let's count how many variants of having two boys and four girls we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, 14, and 15. So as you see, there are 15 different variants how a family of 6 children may have 2 boys and 4 girls. So 15 out of 64 would be this variant of having 2 boys and 4 girls. This is going to be a probability. So now we have to use some rule. We have to add all these independent probabilities in order to find combined probability of having fewer than 3 male children in a family. So 1564 plus 6 over 64 plus 1 over 64 would give us 22 over 64. And if you need an answer in percentage form, you have to divide 22 by 64, and the answer would be, so if we divide 22 by 64, we are going to get 0.34375. And now we have to multiply by 100, because all our calculations were on the scale between 0 and 1, and when we give an answer in percentage form, we have to give on the scale between 0 and 100%. So the answer would be 34.375%. If you need rounded answer, this would be 34%. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any, and share this video with your classmates. And see you in the next video. Goodbye.